Hi everybody, and welcome to tonight's video where we are going to be doing something that's going to be a little bit different than the videos we've done so far, in that instead of doing some explanation and note-taking from the video, really what we're going to do is focus on just working through some examples together. So we talked about exponential functions today in class and defined those and some other topics related to exponential functions, including properties of exponents. So what we're going to do tonight is some examples that you will be able to practice on your own with problems from the book after the video. So the first thing that we're going to talk about is evaluating exponential expressions, and what I have here is use your calculator if necessary. So we have some examples right here to evaluate these expressions. For the most part, you should be able to evaluate something like 5 squared equals 25, right? That should be easy. But when we see these exponents here like 1.7, 1.73, 1.732, and the square root of 3, we're going to probably need our calculator to do that. And you can use your graphing calculator, or you can use Desmos, which I'll use Desmos here. If you're using your graphing calculator, you might see that you'll have a button that's similar to something like this, where it'll have like a to the b, and which point, if you're going to type something in, so let's do the second one that's there, 5, and we want to raise that to the 1.7 power. So when I hit this a to the b, what that does is it puts the cursor up in the exponent, so it moves it up so that it's a super text, so it's up above. So we could type in 1.7, and there's our answer there, 15.426 if we rounded that to 3 decimal places. Now on your calculator, you might see a button that looks like that. This one here, this a squared, that just automatically inserts a squared, and the reason they have that is just because you would use a squared term more commonly maybe than other exponents, so they have a separate button for that. You might also see what's called a caret, which looks like this symbol, only kind of on its side, so it's pointing up, right? And that would also, what that does is it moves the cursor up, and so anything coming after that would be an exponent. So we have 5 to the 1.7 power is 15.426. So we'll write that over here, 15.426. And then we have 5 to the 1.73. So if we go back, 5 to the 1.73, we get 16.189. 16.189. Then 5 to the 1.732, and so really all we're doing is adding numbers here. So now it's 16.241. 16.241, and then lastly the square root of 3 power. So let's delete all that, and then square root of 3 is 16.242. The reason that the book does this, and you're going to have some problems that are like this on your own, this is to kind of illustrate that when we have an exponential expression, when we have 5 to the x, remember you're plugging in different values of x here, and a domain that's continuous of all real numbers. And all real numbers include these irrational numbers that could go on forever, right? So 1.7, 1.73, 1.732, radical 3, those would all be elements of the domain of 5x. What this is trying to kind of show you is that as you extend these numbers, the values get closer and closer together. So it's kind of to illustrate the fact that you have a continuous graph when you have one of these functions here. Okay, so moving on. Now we're going to solve some exponential equations. And for these, there's really 2 steps. First thing that you want to do is write each side of the equation as an exponential expression with the same base. And you'll remember that from our conversation in class today. You should have your notes with you as you're watching this video. So you're going to write them as an exponential expression with the same base using our properties of exponents. Again, we talked about that today in class. And then once you have the bases that are the same, you can set the exponents equal to one another. And then that's a simple 1 or 2 step algebra problem to solve for your variable. So let's do some examples here. And we'll start with 3 to the negative x equals 81. So if I'm looking at those two numbers, I want to get them with the same base. So the base is the number that is being raised to a power. So in this case, this is 3 to the negative x. There's not much I can change there. Over here I have 81, and what I'm going to try to do is rewrite that as an expression of a power of 3. And I know that 81 is 3 to the 4th. And so now what I have are two expressions written to the same base 3. So you're going to have to know your values for the different, I'd say the number is at least 1 through 10 raised to anything from the first to the 5th power. You should kind of have an ability to kind of recognize what those values are. So that now once you have this 81, you can quickly see that that's 3 to the 4th, and now you have 3 to the negative x equals 3 to the 4th. If that's the case, what you do now is set those exponents equal to each other. So this tells me I can do that. Negative x equals 4, so that means x equals negative 4 by dividing both sides by negative 1. Great, so that's a kind of straightforward, easy one. Let's try another one. Let's say I have something like this, 5 to the x plus 7 power equals 1/5. And my properties of exponents would remind me that when I have a fraction, 1 over 5, that's really 5 to the negative 1st. And so now I have same base on both sides, so I can say x plus 7 equals negative 1, and then simply all I have to do now is subtract 7 from both sides, and I would get x equals negative 8. Okay, so those are kind of straightforward. You got to remember my properties of exponents, and you should have that table with you from class. And then we'll try one more. This one will be a little more complicated. Let's say we have 9 to the negative x plus 15 power equals 27 to the x. Okay, and so I'm looking at these two numbers here, and I can't write 27 as a base of 9. Right over here, that was easy. 81 could be written as a base with a base of 3. Here, these numbers, I can't write them. I can't just write this one as the same as that. So looking at 9 and 27, is there another number that they could be written with the same base? And that would be 3. So 9 can be written as 3 squared to the negative x plus 15 power. And 27 is 3 cubed to the x power. And now I'm going to apply my properties of exponents here. And when I have a power to a power, what do I do with the exponents? I multiply them. So this is 3 to the 2 times negative x plus 15. So that's the negative 2x plus 30 power, right? Because I'm multiplying this 2 times this whole quantity. So I distribute it. And so that equals 3 to the 3x power. So now I had to do a couple extra steps here to be able to get this as two expressions with the same base. And then I can set the exponents equal to each other. So negative 2x plus 30 equals 3x. You would add 2x to each side, and you get 30 equals 5x. Divide by 5, and you get x equals 6. Okay, so those are 3 examples right there of some problems that require you to solve for x when you're given 2 exponential expressions, or in other words, an exponential equation. Write them in the same base and solve. Okay, so like I said, this is going to be a unique video. So we just had a few examples that should help you complete the following problems, and this is what you're going to do with the rest of homework. So the video is short, under 10 minutes, so you can use this in your notes to complete these problems and bring them to class tomorrow. I'm going to expect you to have questions on numbers 71 and 75. That's okay. That's what we'll start class with, reviewing that. So I'll check this, check your notes, make sure that you did these problems, and I'll see you in class tomorrow. Have a great night.